Today's video, we are covering 7.5 inverse trig functions. And what we're doing today is really important. We're going to continue this work on inverses and kind of all different types of ideas with them. And it'll help us with some solving equations as well. So what I'd like everyone to do right now is go ahead and try the warm-up. Give me an answer for A and B in the Edpuzzle. Any answer that'll work is fine. And then we'll talk about these answers. Go ahead and do that now. Hopefully you did some work for part A. You might have drawn a triangle with the 315-degree angle. You may have, from there, dropped that vertical to create the 45, 45, 90 triangle. You know the sides of the 45, 45, 90 are the root 2 halves, and 1. Notice how my x side I'm leaving positive, but the y side I'm leaving to be negative. Now then we want to use our cosine here. Cosine of 315 degrees is what I'm trying to find. So cosine of this triangle from the reference angle would be the adjacent side over the hypotenuse, which is 1. So it's just the x side of this. So my answer is root 2 halves. Now that is the only possible answer here. I do not want a decimal. I want exact form always for these guys. And that's it. One answer. However, when you do part B, what you're going to find is there's a bunch of answers for this. Sine could be negative in 2 quadrants, first of all. Sine is the y side of the triangle. And that could be negative in both quadrants 3 and quadrants 4. Both of those would make triangles that have a reference angle of 30 degrees, aka pi over 6. And then I could refer to each of those angles in many different ways. So different possible answers to this would be my angle could be 210 degrees. It could be 330 degrees. It could be negative 30 degrees, etc. And the list goes on. I could also have answered in radians. So my angles could be 7 pi over 6. They could be 11 pi over 6. They could be negative pi over 6, etc., and the list goes on. So all of these are solutions. In fact, technically, there is an infinite amount of solutions to this problem. So what's different about the 2 problems in example 1? So in this first problem, part A, we are solving for a trig value. Solving for a trig value. I'd like you to write this down. This vocab here is important. A trig value, which means our answer is a number. We are getting out a number. And there's only one answer. Only one answer. Okay, but then when we go to part B, now we are solving for an angle. We are solving in part B for an angle. For theta, which represents an angle. And our answers are going to be angles in degrees or potentially in radians, and that may be specified for us. And in this, there is not only one answer. There are multiple possible answers that could work. In fact, there's an infinite amount of answers. So how do we deal with an infinite amount of answers? Well, one option is we'll give you angle restrictions to solve within. And then later on, we're actually going to learn about natural inverse restrictions that apply as well. We're not going to get into all of that today, though. Let's go ahead and go through some vocab first. So some vocab for inverse trig functions. The function called arcsine, A-R-C-S-I-N-E. The arcsine function, which is also known as the inverse sine function, is defined by arcsine of x equals sine inverse of x. Notice each of those notations. And what that is it's the angle in a right triangle whose sine is x. We have one of these for each of our normal functions. So the inverse sine is called arcsine or inverse sine. Then we have another one. So we've got the arc cosine function, arc cosine function or inverse cosine. Function is defined by arc cos of x or cos inverse of x. And what that is it's the angle in a right triangle whose cosine is x. And then we have another one. We have arc tangent function, the arc tangent function or the inverse tangent function. And what that is it's arctan of x, or tan to the negative 1 of x is how we write it. And what it is it's the angle in a right triangle whose tangent is x. These little bullets here are intended to be some vocab words that you need to be familiar with, and also to give you some notation that you need to be able to understand and write and use fluently. So make sure that you've got all that down and you're comfortable with that, because we're used to seeing inverse sine or calling it inverse sine. We're not used to arc sine, and textbooks can use either vocab. So you want to make sure you're very fluent with both of these. This means for any angle, we're going to use theta to represent our angle. There we go. In a right triangle, other than, of course, the right angle, if sine of theta is equal to x, then theta is sine inverse of x. And you did this in a geometry class, so you have seen this. If cos of theta is x, then the angle theta is cos inverse. If tan of theta is x, then the theta is tan inverse of that x. So to get an angle by itself, you just do the inverse trig function to the other side is essentially what we're doing here. Notice I use the notation with the negative 1 more frequently, but we could also write those now as arcsine, arccos, and arctangent. Okay, so let's talk about angle restrictions. Example 1, evaluate the inverse trig function. Are there multiple answers? Give as many as you can. Go ahead and put in the Edpuzzle one solution to this problem. And you might have realized that there are multiple solutions to this problem. Answers that would work here include 30 degrees, negative 210 degrees, negative 330 degrees. We can get really creative with this. All of those would be fine. You could have said 5 pi over 6. You could have said pi over 6. You could have said negative 23 pi over 6. So you can give me a positive angle, a negative angle, a coterminal angle, an angle in degrees, an angle in radians. There are an infinite amount of these. So what we are going to do is we are going to restrict the angles that we use. We are going to restrict our angles that we use because this is too many. And if I'm going to try to grade this and everyone gives me a different answer, that gets crazy. So let's go to example 2 to see how we use angle restrictions. Here are your angle restrictions right here. Angle restrictions. Go ahead and identify those, highlight them, or whatever. So evaluate each inverse trig function for the angle restriction 0 to 2 pi. Give an exact answer whenever possible. So this means that I want all angles between 0 and 2 pi, including 0, not including 2 pi. Because those restrictions are in radians, that also implies my answers have to also be in radians. Answers in radians. Because the restrictions are in radians. So we always match our answers to the restrictions. So let's go ahead and try a problem. Where is tan inverse going to be root 3? Remember, tan inverse of a number, this root 3 is a number, gives me out an angle. If it helps you, you could rewrite this as tangent of what angle is root 3. You can do that if you want. Now, I like to think of tangent as my y side over my x side. So let's go to quadrant 1 here and draw the little triangle. And this is my y side and this is my x side. And I know tangent is the ratio of y over x. So if I want to get out a root 3, I'm thinking that probably came from this ratio of sides. Now, that might not be obvious to you right now, and that's okay. This takes a little while to get used to. I know that root 3 is going to come from either root 3 halves over 1 half or the flip of that. So it's going to come from my 30, 60, 90. So my options were root 3 halves on top or root 3 halves on bottom. On each of these fractions, you're able to just cancel denominators. You can multiply by 2 over 2, and it'll get rid of those 2 denominators. So this one gives you a root 3. This one gives you a 1 over root 3, and you have to then rationalize it. So by kind of reverse engineering that, what I'm figuring out here is that my y sides and x sides are the root 3 halves and the 1/2. The y specifically is the root 3 halves and the x is 1/2. Tangent is a little harder than the other functions, so bear with me here. Now I see that y over x would reduce to root 3. So this is definitely correct. Well, I want to figure out what's this angle. Since this is across from the root 3 halves, the middle side, it's my middle angle. So it's the 60. Out of the 30, 60, 90, this is the 60 degrees, but I'm in radians. So I'm going to call it pi over 3. So pi over 3 is one answer, but tangent is also positive over here in quadrant 3. So tangent also has an answer that comes to quadrant 3. So pi over 3 is one answer. The other answer is pi plus that reference angle pi over 3. And pi plus pi over 3 would give me a 4 pi over 3. And those are going to be my two solutions that get me there. Now, some of you might be picking this up and going, yes, this makes sense. And some of you might be going, wow, this is a lot here. If you're finding you really struggle with this, please schedule office hours ASAP, because we're going to continue to use this thinking as we move forward. And it really takes a while to get the hang of this. But if you don't start asking questions, then it's going to be hard to proceed. Let's try another one. When I go to part B, I want cos inverse of 1/3. So again, I'm solving for some angle. If you want, you can write it as cosine of what angle is 1 over 3. So before I do this, what I actually like to do is identify which quadrants I'm in. So let's think about where cosine is positive. Everybody's positive in the first quadrant. And since cosine is the x side, it's also positive in quadrant 4. Now, when I look at that side 1/3, I don't recognize it. What I mean is it's not a special side from the unit circle. It's not my root 3 halves or my 1/2 or my root 2 halves or whatever. So I have to do this one with calculator. I have no other option. What you're going to do is you're going to make sure that your calculator is set in radians. To do that, you hit the math button. Nope, you hit the mode button. Hit the mode button on your calculator, scroll down, and there's a radian or degree options. Choose radians. You are then going to type in cos inverse of 1/3 on your calculator, and your calculator will give you an answer 1.23. And what that is that's this angle here, 1.23. So you're just using your calculator because it's not a special right triangle value that we know. Cos inverse on your calculator, 1.23. Well, that's the same size reference angle in here. So now what we need to do is we need to figure out how to get this angle. To get that angle, let's do 2 pi and then take away the 1.23, and it'll backtrack us to our terminal side. So the second angle is going to be 2 pi minus, and don't use 1.23, use the exact value from your calculator. So go 2 pi minus answer, and the second answer you should get is 5.05. And those are the only two places where cosine will equal positive 1/3 on a unit circle. Okay, let's try another one. Sine inverse of negative root 2 halves. Sine is negative in 2 quadrants. Which 2 quadrants is sine negative in? Go ahead and choose that in the Ed puzzle. Hopefully you chose quadrants 3 and 4. Remember, we're trying to find an angle. So if you want to rewrite this as sine of what angle is negative root 2 halves, you can. What I like to do is I like to label that side length on my triangles. Sine is the y side of the triangle. So that's going to be this side, and that's going to be this side. And if you're still struggling with that, that takes a little while to get used to, but keep practicing it. I know that root 2 halves is always a 45-degree angle. So these reference angles are pi over 4. And so then I'm going to find my two answers, pi plus pi over 4, which is 5 pi over 4, and then 2 pi minus pi over 4, which will give us 7 pi over 4. And those should be your two solutions on part C. One more problem for us. Tangent. is equal to positive 1/2. Remember, tangent is positive in quadrant 1 and also quadrant 3. We are trying to find the angle that solves this. We want to find tangent of what angle is 1/2. Again, 1/2 is not a side ratio I know for tangent. So again, I have to use my calculator on this. Have to, no option. So if it's a special angle from the unit circle, don't use a calc. If it's not, then you are forced to use a calculator. Fine. So you type this in on your calculator, and your calculator gives you 0.46. That's this little angle here. So to find the other angle, remember the reference angle is the same. So we're just going to go pi plus 0.46. So you're going to add pi to that, pi plus answer, hit enter, and you'll get your second answer, 3.61. And those should be your two solutions for the two angles, the quadrant 1 angle and the quadrant 3 angle. Let's wrap this up with a couple quick problems here. So on example 3, there's this problem about Flagstaff, Arizona, and roofs. And they say that they want steep roofs to prevent roof collapsing from snow accumulations. And so they design the snow-safe roof with a pitch of 8" 12, which means the slope is 8/12. So remember, that's like a rise over run situation. So we have some side lengths there. So if I want to find this angle, I'm just thinking I'll probably use tangent here. Tangent of theta is 8/12. If you do this on your calculator and you type in tan inverse, your calculator is probably going to give you 0.59. And what that is the radian value. And I did say moving forward that we'll almost exclusively use radians, and that's true. However, in real life context, sometimes we'll use degrees, because if you came over and said, what's the angle of your roof? And I said 0.59 radians, we don't really know what that looks like. So what I want you guys to do here is change your calculator back into degrees. Again, go to the mode button and choose degrees. And then get the degree answer for this, and we'll get 33.7 degrees. Sometimes we'll do degrees for word problems because we have a better sense of what that looks like. Either of these would be fine, and on a test or quiz, we'll always specify what we want. Well, there are natural angle restrictions in word problems. The angle can't be smaller than 0. It can't even be 0 or it wouldn't exist. So it has to be larger than 0, can't include it. And it can't be bigger than 90 because we see that's an acute angle. So sometimes word problems come with their own kind of natural restrictions, and you have to go through and interpret those on your own. If you were in radians, then 0 to pi/2. And that would be a fine way to answer this problem. Just degrees would maybe make a little more sense if you were actually talking to a person about the angles of their roof. Go ahead and finish example 5. They want you to find to the nearest tenth of a degree both of these angles. So notice they want you in degrees. And notice we're going to get answers that are less than 90 degrees because it's in a triangle. So it wouldn't make sense to have any bigger angles when I'm in a right triangle already. Go ahead and give me answers for both of those in degrees, submit them to the Edpuzzle, and then you guys are done with your video for today.